on B hash open sets and other classes of sets. Well, modern mathematics knows various families of subsets which are associated with a given topology but have properties weaker or sometimes stronger than those of typical standard open sets. So if X with topology tau is a topological space, then a subset A contained in X is called alpha open if A is contained in interior of closure of interior of A, semi-open if A is contained in the closure of interior, pre-open if A is contained in the interior of its closure, beta open or sometimes semi-pre-open if A is contained in a closure of interior of closure of A. And finally, regular open if A is equal to interior of its closure. Analogously, we may define various approaches to the notion of closeness. A subset A is called alpha closed when the following holds: closure of interior of closure is contained in A, semi-closed, pre-closed, beta closed, and finally regular closed if A is equal to the closure of interior of A. Moreover, there are also other classes. In fact, there are many other classes. For example, Indira and Reka studied, well, let's say star B open sets and double star or star star B open sets. Bharati, Bhuvaneshwari and Chandramati introduced the notion of B star star open sets, and Andreevich studied B open sets. Well, we say that A is, for example, star B open if it's contained in the intersection of its closure of interior and interior of closure. Star star B open if it's contained in the intersection of interior of closure of interior and closure of interior of closure. B star star open in this case, as you can see. And finally, B open if A is contained in the union of closure of interior of itself and interior of closure. However, Ushma Parameswari and Thangavelu proved in their paper Look to the Bibliography, they proved, among many other things, interesting things, that, for example, B star star open sets are identical with beta open sets, and star star B open sets are identical with alpha open sets. So these notions, B star star and star star B, are redundant, yes, and maybe we do not need them. Or maybe we can treat them as another characterization of this previously known sets, previously known classes. Well, in fact, both Parameswari and Thangavelu proved also some other results of this kind, and then they have introduced so-called B hash open sets. Let X with tau be a topological space. Then A contained in X is called B hash open if A is equal to, not only contained but equal to, the closure of interior of A plus, yes, union with interior of closure of A. And one can prove that any B hash open set is B open, but the converse is not true, and here you have a kind of counterexample. You may study it to find that the singleton of C is B open, but not B hash open. Yes, you have to perform some calculations. Furthermore, our authors proved that B hash open sets are identical with the class of those sets which are simultaneously star B closed and B open. Because of course if we had the notion of star B openness, then it's also possible to define star B closeness, yes. There are also many other properties. For example, Let X tau be a topological space and tau alpha be a collection of alpha open sets. One can prove that alpha open sets form topology too. And now we may replace typical interior closure by with alpha closure and alpha interior, and define B hash openness in terms of alpha closure and alpha interior, and then A contained in X is B hash open in tau with respect to topology tau, if and only if it's B hash open in tau alpha. So with respect to this topology, which is given by alpha open sets. This is because, yes, the following relationships hold. Moreover, if A is B hash open, then if it is also open in a standard sense, then it's closed. So it's both closed and open. Yes, as we know, such sets certainly exist. If A is B hash open, then if it is also star B open, then it's both regular open and regular closed. And there are many other properties of this kind. This is interesting. One can prove that arbitrary union of B hash open sets need not be B hash open, and the same with arbitrary intersection. And there is an interesting counterexample in the paper by the authors, by Parameswari and Thangavelu. Well, consider real line R, real numbers with the most standard typical topology generated by open intervals. One can prove that each closed interval of the form AB, where A is lesser than B, is B hash open. Now let A be smaller than B, and let us define the following sequence of intervals, of closed intervals: A plus 1 over n, B minus 1 over n. Yes. Then their union, clearly their union is just open set AB, open interval AB. However, this interval is not B hash open because we may calculate closure of interior of AB. This will be closed set AB. Interior of closure of AB. So this will be open interval AB. Then we calculate their union and we obtain closed AB. But of course, closed AB is different than open AB interval. So the very basic condition of B hash open sets, which was defined here, is not satisfied. Similarly, we may consider Bn the following sequence of closed intervals: A minus 1 over n, A plus 1 over n. So we are getting closer and closer to A on the left side and on the right side when n is increasing. Then the intersection, infinite intersection of the sequence of Bn's is just singleton of A. However, again, we may calculate union of closure of interior and interior of closure. This will be empty set. And of course, empty set is different than non-empty singleton. So singleton of A is not B hash open. As usual in such cases, it's possible to define, for example, B hash continuity and B hash irresoluteness. And in fact, Ushma Parameswari and Thangavelu have already stated all these notions. The same can be said about separation actions based on the idea of B hash open sets. And so they have introduced B hash Ti actions, for example, T1, T2, and the notions of B hash regular space and B hash normal space. They've also considered B hash open sets in the context of the notion of connectedness. Yes. And disconnectedness and density and no density. So their paper is interesting. Here we have bibliography. This is the very basic paper on B hash open sets, published in 2014. And this one is about B hash separation actions, published in 2015. Thank you very much for your attention.